The end of prompting. How to build the Copilot agent fabric. Prompting is a bridge to a world that no longer exists. For 3 years, we've been told that better adjectives and longer instructions would unlock productivity. We were told to write more detailed prompts, chain our thoughts, and ask the AI to think step by step. And it worked for about 6 months, then something broke. Most people use Copilot like a search bar. They ask it a question, they get an answer, and they move on. It feels productive, but it's not. Because that assumption that Copilot is just a better search interface is fundamentally broken. You're not here to learn how to write better prompts. You're not here to master the art of adjectives or learn the latest prompt engineering framework. We aren't going to spend 30 minutes on prompt craft. We're here because the shift from execution to orchestration is already happening. And your organization is either building toward it or falling behind it. If this changes how you think about agents, Copilot, and the future of work in 2026, subscribe to M365 FM. You'll stay ahead of the shift. The flaw in the chatbot model. The industry sold you a chatbot, but what they should have sold you is a reasoning layer. Here's what actually happened. You licensed Microsoft 365 Copilot, and it arrived as a text box in Word, Excel, and Teams. Your IT team rolled it out, people experimented, and a few early adopters found uses like drafting emails, summarizing meetings, or brainstorming headlines. It felt magical. Adoption metrics looked good, and usage spiked. Then it plateaued. Most organizations are stuck in the old model of manual interaction. User opens Word, user types a prompt, user waits, user reads the output, user decides if it's good enough, if not, user rewrites the prompt, user waits again. This loop repeats 5 times, sometimes 10 times, and eventually the user just does it themselves because it's faster. That's not a productivity system. That's a tax on your workflow. The reason for this is that you're treating the AI like an assistant that needs constant supervision. You're treating it like an intern who needs feedback on every draft, or like a tool that's smart enough to help, but not smart enough to own the outcome. Prompt engineering is a low-leverage trap for architects. It looks like control, and it feels like customization, but it's actually a tax on every single user. Every person who touches Copilot becomes a prompt consultant. Every workflow depends on the user's ability to ask the right question in the right way. That scales to nothing. It doesn't compound, it doesn't improve, it just spreads the manual work further. The most insidious thing about the chatbot model is the usage cliff. It's real, and you can track it in any organization. Week 1 of Copilot adoption is excitement. Week 4 is experimentation, and week 8 is the novelty wearing off. By week 12, the people who aren't getting immediate value from asking questions have simply stopped asking questions. That's not because Copilot is bad, that's because the interface is broken. Most people think the problem is the AI. They say it's not accurate enough, it hallucinates, or it needs better fine-tuning, but that's not the diagnosis. The diagnosis is this. Your organization is asking individual users to manage the complexity of a system that should be automated. The shift from task-first to outcome-first thinking solves this. Task-first means generate a draft of this email. Outcome-first means respond to every inbound customer email within 2 hours with a draft that maintains our brand voice, flags urgency, and suggests next steps, all without human intervention. One of those scales, the other one doesn't. Here's where most organizations break. They invest in Copilot, train users on prompting, and declare victory. They measure success in number of users who've tried it or percentage of daily active users. But they never measure what actually matters. Did the outcome improve? Did the workflow speed up? Did the person have to supervise the AI? Or did the AI handle the work? Your productivity isn't stalling because of the AI. It's stalling because of the interface. You built a chatbot delivery model. You needed an orchestration model. And that shift from prompt-driven assistance to agent-driven orchestration is where the actual 100x productivity lives. Defining the Copilot agent fabric. So what replaces the chatbot model? The Copilot agent fabric. Think of it not as a single intelligence, but as a networked system of specialized intelligences where each one owns a specific domain. Each agent has its own knowledge, its own tools, and its own decision-making logic. They don't overlap or argue, but instead hand off work to each other based on context and expertise. A standalone Copilot is monolithic. You have one AI, one context window, and one set of instructions trying to be smart about everything at once. It knows your email, your calendar, your files, your policies, and your team structure, but all those details compete for the same reasoning space. The result is a generalist that's an expert in nothing, working until it doesn't, hallucinating on details, and failing to sustain complexity. A skill-based agent is different because it's narrow and focused on one outcome. Because it's responsible for that one result, it owns the entire workflow to deliver it. It has access to specific data and knows the rules that govern its domain. It's been tested for that domain, and it can fail safely because failure in one narrow area doesn't compromise the whole system. This is where skills become critical. They're the evolution of the standard operating procedure, or the SOP, which every organization already has. Hiring procedures, quote, approval processes, and customer onboarding checklists have been documented as PDFs and Word documents for decades. We've trained people to follow them and measured whether they did, but the execution was always manual. But here's what changed. SOPs were always meant to be executed by humans, but now they can be executed by agents. A skill is an SOP that's been translated into a language an AI can follow, improve, and reason about. It uses the same structure and the same logic, but it's no longer blocking a human, it's freeing one. The fabric itself rests on 3 pillars: event, reasoning, and orchestration. Event is the trigger. Something happens in your system, like an email arriving or a deadline passing, and that event reaches an orchestrator. The orchestrator looks at that event and asks what outcome is required and which agent owns it. Reasoning is what happens inside the specialized agent. It takes the event context and retrieves relevant data from business systems and knowledge sources to make a decision. This happens in isolation from every other agent, which means there's no context overload and no reasoning about 5 different domains at once. One agent, one domain, one outcome. Orchestration is the glue. It's the parent agent that receives the event, selects the right specialist, and passes just enough context to make the decision. It waits for the result, then either responds to the user, passes the work to the next agent, or triggers an action in your business systems. This creates a personal AI operating system for the organization. Each department gets agents that understand its domain, and because each outcome is measurable, every failure is isolable and fixable. The whole system runs continuously without needing constant supervision. It actually gets smarter as it processes more work, because every failure teaches the agent what to do differently next time. This is the structural shift. It isn't about better prompting or more data in the context window, it's organizational redesign. The work moves from a person asking an AI for help to an AI owning the workflow end to end. The person becomes a designer of agents rather than a supervisor of outputs. But to build this, we have to look at something most architects skip, which is the data. An agent is only as intelligent as the data it can reason over, and most organizations' data is a catastrophe waiting to happen. Grounding, the architecture of truth. Here's the problem architects don't want to face. Copilot is only as smart as the graph data it can reason over, not your prompts or your model's training. It's as smart as the data, and most data in most organizations is structurally incoherent. When Microsoft Graph indexes your environment, it's looking for meaning. It wants to know who approved a file, when it changed, and what depends on it. It's trying to build relationships so that when Copilot reasons over your content, it understands context and authority rather than just finding documents. But if your SharePoint is a flat dump of folders named Archive and Final, the graph has nothing to work with. It can do keyword search, but it cannot reason. An agent without reasoning capability is just a faster search box. The industry sold storage mapping for 20 years, telling you to move your file shares to SharePoint and keep the same folder structure. This approach is killing agent performance across every organization that bought it because the agent inherits the incoherence. Copilot looks at your content and sees noise. You need semantic modeling instead. Semantic modeling means designing your information architecture around what the agent needs to reason about, not how you've been filing things for the last decade. You have to ask what relationships matter and what signals an agent needs to make a decision. Metadata is what transforms data into knowledge. Consider a quote generation agent. It needs to know which customers have approved pricing and what the approval hierarchy looks like. That's not information buried in documents, and it's not something a human can find by scrolling through shared folders. That's relationships. It must be structured, queryable, and verifiable. If your contracts live in one library and your pricing in another, the agent has to guess about relationships. It has to hallucinate details it can't verify, and it gets it wrong half the time. Instead, structure the metadata so relationships are explicit. A contract should have properties like approved by and effective date linked to your HR records and product taxonomy. Suddenly the agent doesn't search, it reasons. It walks the relationships and constructs a coherent picture. This is why file share lift and shift is the silent killer. You moved the files, but you didn't move the thinking, so the agent still can't reason. Structuring metadata transforms what the agent can do. Metadata is signaling. It tells the agent how to rank and reason instead of just finding. High-signal relationships like owned by or supersedes show authority and what's current versus what's legacy. You're designing for answerability. That means using atomic records over text blobs. A text blob is just a Word document describing a policy, but an atomic record is a structured entry with fields for effective dates and customer segments. The agent can't reason over a blob, but it can interrogate a record. This is structural work. It's not sexy and it's not about the latest feature. It's about whether your organization's information makes sense to an intelligence that doesn't have decades of tacit context. Most organizations haven't done this because they've treated information architecture as a filing system problem rather than an intelligence problem. Your agents will operate at the ceiling of your schema quality. You can have the best reasoning layer in the world, but if the data underneath is incoherent, the agent produces incoherent output. And when that happens, executives stop using it. This level of structured reasoning requires something architects keep underestimating. It requires a protocol. The 100x workflow, quoting as a case study. Let me make this concrete. The shift from faster prompting to agent orchestration doesn't live in theory, and it actually lives in the workflows where time and compliance collide. Think about a manufacturing company receiving a request for a complex quote. The customer has a specific SKU, a certain volume, and a particular geography that requires expedited delivery. This person has been a customer for 3 years, but they haven't purchased this specific product category before. To get this right, the quote needs to account for volume discounts, regional pricing variations, and inventory constraints. You also have to check if they qualify for fast fulfillment, what the current profit margin looks like, if there are active promotions, and which executive needs to sign off based on the deal size. In the old model, here's what actually happens. A salesperson receives the request and opens a spreadsheet of customer records to check credit history, which usually takes about 5 minutes. Then they navigate to the pricing database, a different system with a different login, to find the base price for that SKU. That is another 5 minutes gone. They check the promotion calendar for 3 minutes, and then they spend 4 minutes looking up the inventory system to confirm availability. Calculating the discount based on volume requires checking a table in a PDF stored on SharePoint, and that takes another 3 minutes. They spend 2 minutes reviewing the approval matrix to see who signs off, and then they finally draft the quote in Word. They are manually assembling numbers from multiple systems, copying and pasting, and checking their math twice because a single mistake damages their credibility. The total time for this process is 60 to 90 minutes. And that is the best case scenario where everything is in stock and no exceptions are needed. If the customer qualifies for a promotional discount that isn't in the standard table, you can add 30 minutes of back and forth with the promotions team. If the deal requires executive approval, you have to add another round trip. When there is ambiguity about whether this customer class qualifies for expedited fulfillment, the salesperson has to call operations, and that eats up even more time. The quote that finally arrives is often inconsistent with the last one sent to a similar customer because the discounts were calculated differently or the salesperson simply forgot a promotion. Finance gets the quote and has to validate the math, which often leads to finding errors and sending it back for revisions. The customer loses confidence and the deal cycle extends. Now imagine an agent owns this entire workflow. The agent receives the same request, but it has been trained on the pricing engine, the inventory system, the customer database, and the approval matrix. It isn't searching for files or logging into different systems because it is reasoning over live data. The agent retrieves the customer record in 3 seconds and looks up current pricing in another 2. It evaluates volume discounts, applies promotions, checks approval thresholds, and calculates the margin impact in about 45 seconds. Finally, it generates a compliant quote in the exact format the company uses, complete with governance notation showing which policies were applied and why. The total time is now 3 minutes. This isn't just a faster version of the old way, it is structurally different. But here is what separates this from good prompt engineering. The agent has encoded the regulations and policies into its actual reasoning. It doesn't guess about discount thresholds because those rules are baked into the system. It doesn't hallucinate about who has approval authority because it follows the actual matrix. Because it is querying structured data instead of assembling numbers from documents, it doesn't make calculation errors. Every quote is consistent because the logic is consistent. This process takes 3 minutes because the agent owns the entire workflow and has eliminated the handoffs. The salesperson doesn't hunt through systems, the finance team doesn't validate math, and the ops team doesn't have to clarify fulfillment eligibility. The work that used to take 8 separate decisions made by 4 different people now happens in one coherent chain. Because the agent logs every policy it applied and every decision it made, compliance audits become trivial. You can trace exactly why this customer got this price and prove the agent followed the rules. This 95% time reduction isn't just about speed. It is about being compliant, consistent, and scalable. 3 minutes per quote means you can generate 50 quotes a day instead of 5, which increases deal velocity and improves margin consistency while decreasing risk. But delivering this level of orchestration requires something most organizations haven't built yet. It requires the agent to have secure, real-time access to live data systems rather than just documents or emails. To do that, you need a protocol. Model Context Protocol, MCP, the tool layer. The agent needs hands, but right now, in most organizations, those hands are broken. An agent can reason beautifully by evaluating complexity and following rules, but if it can't reach the systems that hold the truth, all of that reasoning happens in a void. It has to guess. It has to hallucinate connections between data it can't verify, and it becomes a more sophisticated version of the very problem you're trying to solve. This is where the Model Context Protocol, or MCP, arrives. I call MCP the USB-C for AI. Before USB-C, you had proprietary cables for everything, which meant different devices, different standards, and different connectors. If you wanted to plug your AI application into your ERP system, you had to build a custom integration. If you wanted to connect to your CRM, you built another one. Adding a data warehouse or a knowledge base meant writing custom glue code for each one, making every connection bespoke and every integration take months. Every system you added to your agent's reach required massive engineering effort. MCP is a universal connector. It is a protocol that defines how any AI application talks to any data system. This doesn't happen through custom APIs or specific vendor integrations, but through a standard, discoverable, and authenticated channel. An ERP vendor can publish an MCP server, and a CRM can expose itself the same way. Your data warehouse, your knowledge base, and your internal APIs can all be MCP servers. Any agent, whether it is Claude, a Copilot, or a custom engine, can connect to them using the same protocol. For architects, this changes everything. Without MCP, you are stuck in an integration debt spiral. You build an agent, and the business says they need it to access the pricing engine, so you build a connector. Then they say it needs customer history, so you build another one. Then it is supply chain visibility, commission calculations, and competitor intelligence. For every new capability, you are writing code, managing versions, and handling authentication differently for each system. With MCP, you move beyond guessing and into querying. The agent doesn't search a document and infer a price. It queries the live pricing system through an MCP server. It doesn't hunt through email for customer history because it calls the CRM through an MCP connector. Instead of scraping data from a spreadsheet, it accesses the actual system of record in real time. The client-server relationship is straightforward. The agent is the MCP client, and your business systems are the MCP servers. They expose their capabilities, what tools they provide, and what data they can access in a standard format that the agent understands. The agent discovers what is available, makes a request, and gets back structured data it can reason over without any guessing or inference. For architects, MCP becomes the primary lever for tool and data governance. Instead of building custom security for each integration, you define your governance, authentication, and rate limiting once. Every system that talks to the agent through MCP inherits that same security posture. You aren't managing dozens of ad hoc connections anymore. You are managing one protocol enforced across your entire agent fabric. Because capabilities are exposed as standardized tools, they are also discoverable. An agent doesn't need to know which systems are available in advance because it can simply query the MCP registry. When it needs to check inventory or look up a policy, those tools are already listed and ready to use. The agent becomes extensible, meaning new systems plug in without requiring new prompts or extra training. You add the capability once at the system level, and every agent immediately sees it. This transforms what an agent can actually do. Instead of working with inferences drawn from documents, the agent works with facts. Instead of assuming relationships, it verifies them. The confidence in the agent's output rises because the foundation underneath is solid. Tools are the agent's hands, and MCP gives those hands reach. But hands without direction are just movement, and the agent still needs the ability to delegate. That is where orchestration shifts from the tool layer to the collaboration layer. Agent to agent, A to A, the delegation layer. An agent with reach is useless if it can't delegate. That is where agent-to-agent protocols enter the picture. A to A is how agents talk to other agents, and I don't mean through prompts or human handoffs. It is a standardized conversation layer that lets one agent ask another to handle a specific part of the work. This is the shift that separates a multi-person experiment from a real enterprise system. Think about what a monolithic Copilot tries to do. It is one agent trying to cover all domains, all contexts, and all responsibilities. It tries to be an HR expert, a finance analyst, a sales strategist, and a compliance officer at the exact same time. The result is mediocrity across the board. It knows a little about everything, but it is an expert in nothing. A federation of specialists works differently. HR has its own agent, finance has its own, and sales has its own. Each one is trained on its specific domain, which means it knows its own policies and owns its own outcomes. They don't compete for reasoning space or argue about priorities. When work arrives that touches multiple departments, the parent agent routes it. It tells the finance agent to calculate the discount approval chain for a deal, while asking the HR agent to confirm an employee qualifies for a benefit upgrade. At the same time, it asks the compliance agent to verify execution in that jurisdiction. The parent waits for all three to respond, and then it assembles the final answer. This requires a contract between agents. It is a protocol that says, if you send a request structured a certain way, the agent will respond with data structured the same way. It promises to complete the task in a specific time frame, log its reasoning, and escalate to a human if certain conditions are met. The parent agent's job is to hold the context. It receives a user request and understands what outcome is needed, knowing exactly which specialists own which pieces of that outcome. It assembles just enough context for each specialist to make a decision without creating information overload or extra noise. Then it validates the responses, stitches them together, and responds to the user. None of the specialists need to know about each other. The HR agent doesn't understand finance, and the sales agent doesn't understand compliance. They don't overlap or try to maintain coherence across different domains. Each specialist improves at its own pace and adapts to changing regulations without ever touching another agent's code. But specialists need an identity. They need a way to announce themselves to the system. This is where agent cards matter. An agent card is a capability manifest that tells the fabric what the agent does, what it needs, and how to reach it. It includes the agent's domain, the inputs it expects, the outputs it produces, and the human escalation thresholds it enforces. When the parent agent needs to route work, it reads these cards. If it needs to know which agent can handle a customer refund dispute, it scans the cards until the customer service agent answers. That agent's card says it takes a customer ID and order ID, and then it returns the approval status and refund amount. The parent doesn't have to guess. It reads the card and knows exactly what it is getting. Agent cards also enable discovery. New agents plug into the fabric by publishing their cards, and existing agents see them immediately. This makes orchestration extensible. You can add new capabilities without retraining the parent, because the parent simply reads the new card and learns how to use the new agent. This works across different time frames. Some workflows finish in seconds, like a pricing query or a policy lookup. The parent asks, the specialist responds immediately, and the work flows to the next step. Other workflows span days. Think about an employee onboarding that touches HR, IT, facilities, and finance. This might involve an approval chain where each step requires a person to validate the work. The parent agent doesn't hold a connection open for days while it waits. Instead, it spawns a workflow where each specialist works on its piece when the work reaches them. The parent checks in periodically to see if IT provisioning is complete or to find the status of a facilities assignment. It sequences dependencies, so it won't tell sales an employee is ready until HR confirms the benefits are active. If an approval is overdue, it handles the escalation by alerting the manager. Long-running workflows are where agent orchestration moves from individual productivity to organizational productivity. One person drafting a document faster doesn't change company revenue. However, 10 people working in parallel on coordinated workflows changes how the entire organization executes. To make this parallel execution work, you need a definition of what each agent does. You have to encode the work itself. That isn't a contract between agents. It is a contract between a person and an agent. That is a skill. Anatomy of a Copilot skill. A skill is not a prompt. It is not a configuration file or a template. It is a specification that acts as a contract between what the agent should do and what it actually does. It is the difference between giving an agent a suggestion and giving an agent a law. Every skill lives in a single file called skill, MD. It is just plain text markdown. There are no databases, no XML sprawl, and no proprietary formats. It is a structured text file that sits in your repository and defines the complete operational logic. That file is non-negotiable. If your skill doesn't have a skill, MD, it isn't a skill, it is just a prompt or an experiment, and it isn't ready for production. The skill.md file contains 4 critical components: metadata, workflow, rules, and reasoning gates. Metadata is how the orchestrator discovers and identifies the agent. It is your identity in the fabric, including your name, version, and activation thresholds. Activation is critical because your skill lives alongside 50 others. The parent agent needs to know if this is the right skill for the job. The description tells that story. It might say, it is a marketing email generator for newsletter campaigns that targets mid-market SaaS and preserves brand voice. That description is how the orchestrator reads agent cards and routes work to you instead of 5 other agents. Poor descriptions create ambiguity, which leads to work bouncing between specialists until the system loses coherence. Metadata also includes your namespace and your promised outputs. You have to define what data structure you expect, like a customer email address or a campaign ID. Then you define what you return, such as an HTML email draft and a tone confidence score. This is the contract. The parent agent sends data shaped one way, and you return data shaped the other way. There are no surprises and no room for interpretation. Workflow is the operational core. It is the step-by-step logic of how you approach the work. This isn't generic advice. It is the exact sequence you follow every single time. First, you might retrieve customer emails from the past 12 months. Second, you extract voice patterns like tone and sentence structure. Third, you read the brand guidelines. Fourth, you synthesize a draft. Fifth, you apply the regulatory language. Sixth, you validate the draft against a checklist. Finally, you return the output with reasoning notes. Each step is explicit. There is no ambiguity about what comes next. The agent executing this workflow doesn't interpret the instructions, it simply follows them. If a step fails because a template is missing, the workflow fails cleanly. The agent doesn't hallucinate compliance language. It reports the failure and stops. That failure then becomes data that updates the reasoning gates. Rules are the guardrails. They are what prevent the agent from hallucinating style or inventing brand language. They are constraints on reasoning that the agent must follow. You might have a rule to never exceed 4 sentences per paragraph or to always include an unsubscribe link. These aren't suggestions. They are boundaries the agent respects, or the output gets rejected. Underneath everything sits self-annealing. This is how the skill heals itself. Every execution and every failure is logged. The agent reads those logs and improves the skill over time. It executes the task and produces an output. If a human reviews it and rejects it because the tone doesn't match the brand, that feedback becomes data. The agent compares the output to the guidelines, identifies the gap, and updates the skill. It refines the workflow and tightens the rules so it gets it right the next time. This requires one fundamental instruction. The agent's job is half execution and half improvement. It must execute the workflow, log the outcome, read the feedback, and update the skill. That is the contract. A skill that never fails is a skill that is never pushed hard enough. But a skill that learns from every failure is production ready. That is how you reach true accuracy. The DBS framework: direction, blueprints, solutions. You have defined a skill, documented the workflow, and set the rules, but now you face a common problem. Your skill is static while your organization is constantly moving. Brand guidelines evolve and regulatory language changes, just as your tone of voice adapts when the market shifts. Approval thresholds update the moment new leadership arrives at the office. If all of that information lives inside your skill MD file, you will find yourself rewriting the entire skill every single time a minor detail changes. You end up touching the core operational logic when you're only meant to update a simple reference document, which creates friction where there should be total clarity. This is exactly why we use the DBS framework to solve the architecture problem. DBS stands for Direction, Blueprints, and Solutions, and it is a three-layer structure that separates what changes from what stays stable. This is how you build skills that can evolve without breaking the system. Direction is your skill.md, which represents your operational intent, the workflow, the reasoning gates, and the core logic. It tells the agent that when it receives work of a certain type, it must follow a specific sequence to produce the desired outcome. Direction is where your decision logic lives, and it is also where the skill is most sensitive to errors. If you get this part wrong, the entire workflow breaks, but the key is that direction should not change very often. A quoting workflow today will likely be the same quoting workflow next year because the fundamental steps do not shift. You aren't reordering the sequence just because a manager had a new idea. Because direction is structural, it only changes when the business process itself changes, not when the brand guidelines get a refresh. Blueprints are everything else in your system, and they live in your references folder. They include your brand standards, voice guidelines, policy language, tone checklists, regulatory templates, customer segmentation rules, and approval matrices. These are context documents that inform how the agent executes the workflow without defining the workflow itself. The agent reads a blueprint and adapts its behavior accordingly, which means the direction layer doesn't even need to know which specific blueprints exist. The direction simply says to apply the brand guidelines while the blueprints live and version separately. You can update them as frequently as you want without ever touching the underlying workflow logic. This matters because blueprints exist in the real world where things move fast. When your compliance team says they need new GDPR language, they simply update the blueprint and the job is done. The direction that references that file never has to change, and the agent just reads the new version the next time it runs. If your brand team decides the company voice should be more direct and less flowery, they refresh the brand voice guide. The blueprint gets updated while the direction stays unchanged, allowing the agent to incorporate new guidance without the engineering team ever touching the operational logic. Solutions are your scripts and your code, including Python, JavaScript, and HTTP requests to external APIs. These are complex calculations that live outside the agent's native language and handle everything the agent cannot do through pure reasoning. They stay in the solutions folder because they are implementation details that only change when the underlying systems change. When your pricing engine API gets a new endpoint, you update the solution script, but the direction and blueprints don't care. They only need to know that a solution exists to look up the pricing data when it is needed. This three-layer structure creates a clean separation of concerns across the company. Business teams own the blueprints, so they can update the voice, refine policy language, or adjust approval thresholds on the fly. Engineers own the solutions, maintaining the integrations, updating API calls, and improving overall performance. The coordination layer, which is the direction, rarely changes because it only moves when the process itself moves. The result of this setup is a remarkable side effect called reusability. Imagine you write a sales email skill with direction that defines a workflow for customer outreach. It references blueprints for brand voice and regulatory language, while calling solutions for signature blocks and compliance footers. Now you need a support email skill, which has a different purpose but uses the same brand voice and regulatory requirements. You can reuse those blueprints easily by writing new direction for the different workflow and pointing it at the same files. Both skills inherit the company's voice without any duplication, so when the brand team updates the guidance once, both skills reflect it immediately. That is the standard for orchestration as we move toward 2026. You don't want one monolithic document trying to cover every single detail, but rather 3 clean layers. You use direction for logic, blueprints for guidance, and solutions for integration. The practical benefit here is velocity. When 90% of what changes is found in the blueprints and those blueprints don't require a full engineering review, non-technical teams can finally own their domain. They refresh the guidance and update the policy language whenever they need to. The direction stays locked, stable, and production grade. That separation between what your organization thinks and what it actually does is where orchestration at scale becomes possible. This is how you move away from experimental agents and start building real operational infrastructure. Specialist delegation pattern. You have your direction, your blueprints, and your solutions ready to go. You have structured the skill, but now you have to decide who is actually going to execute the work. This is where architects have to make a critical choice. You could build one giant agent that knows everything about your entire organization, or you could build a council of experts. This council consists of agents focused on narrow domains with a parent agent that coordinates everything. The generalist bot is a tempting idea because it offers one interface, one set of instructions, and one place to apply guardrails. It feels clean and simple at first, but in reality, it is neither of those things. A generalist bot trying to handle HR policies, sales strategy, and financial forecasting all at once becomes a reasoning nightmare. The context window fills up with unrelated knowledge, and the agent wastes cycles trying to decide which domain to engage. It eventually makes mistakes at the boundaries between domains because it isn't a true expert in any of them. You end up with an agent that is competent at nothing. The Council of Experts works in a completely different way. You have an HR agent trained specifically on labor law and benefits, and a sales agent that understands pipeline dynamics and deal mechanics. You add a finance agent that knows cost structures and approval authorities, along with an IT agent for infrastructure and system architecture. None of these agents overlap or second-guess each other. So when work arrives in a specific domain, the right expert owns it. However, this setup creates an orchestration problem that you have to solve. The user never talks to the HR agent or calls the sales agent directly, but instead communicates with one interface called the parent agent. The parent is responsible for understanding what the user needs, routing the request correctly, and assembling the final answer. The parent is the sole responder to the user, and this rule is non-negotiable. If the HR agent starts answering the user directly, while the sales agent is also responding, you will have total confusion and conflicting guidance. The parent must own the conversation so that everything else remains invisible to the user. This pattern requires a lot of discipline when it comes to scoping your agents. The HR agent should not handle payroll because that is an accounting detail, and the sales agent should not calculate commissions because that belongs to finance. Each agent must have a clear perimeter so that when work touches multiple domains, the parent can coordinate effectively. It doesn't just merge the answers together, but assembles them into a logical response. It tells the user what HR says about benefits and what finance says about the cost, providing one integrated recommendation. Proper scoping prevents domain creep and keeps agents from accumulating too many responsibilities. It forces you to be explicit about ownership, and that explicitness is what allows the system to scale. When new work arrives, the parent reads it and realizes it is an HR question, so it routes the task to the HR agent immediately. Because the agent wasn't designed to answer anything else, it doesn't waste any context trying to figure it out. This leads to the hardest problem in multi-agent orchestration, which is context overload. Every agent you load into memory costs tokens, and every set of instructions or guardrails consumes valuable reasoning space. If you load 5 agents at once, you have burned a significant amount of context before the real work even begins. The parent agent actually gets dumber because it is trying to carry 5 entire expert systems in its head at the same time. The solution to this problem is lazy loading. You should not load specialists until the exact moment you actually need them. The parent agent stays lightweight because it only knows which specialists exist and which domains they handle. It does not hold their full instructions in memory until a request arrives and the parent identifies it as HR related. At that point, it instantiates only the HR agent and loads its specific direction, blueprints, and solutions. Once it gets the answer, it unloads the specialist to keep the reasoning space clean. This allows multiple agents to participate in the orchestration without creating a context monster. This approach requires your agent registry and your agent cards to be easily scannable. The parent agent needs to read the metadata on those cards to make routing decisions without loading the full instructions. This is why your card descriptions matter so much, as they are the lightweight signals that tell the parent exactly who to call. But here is where most multi-agent systems fail, and it usually happens during the handoff itself. The technical architecture might be perfect and the routing logic might work, but something breaks in the transition between agents. An agent might return data that the parent doesn't understand, or the format isn't what was promised. The parent tries to use that data, and that is when hallucinations take over. Sometimes the specialist agent makes an assumption about the parent's context that simply isn't true, and they end up talking past each other. This is why testing the handoff is where you need real engineering discipline. You cannot just test each agent in isolation, but you must test the handoff between them relentlessly. You have to ensure the parent correctly passes the specialist's response and routes the work to the right place. It needs to handle error states and know when to escalate to a human if the specialist cannot proceed. Multi-agent systems don't usually break inside the agents themselves, but in the empty spaces between them. Progressive disclosure, saving your context window. There is a technical reality about large language models that architects often ignore because it's uncomfortable. As the context window fills up, the model actually gets dumber. It doesn't just get slower. The quality of its reasoning starts to fall apart. Hallucination rates go up, and the ability to stay coherent across a complex decision just degrades. This isn't a bug we're waiting for a patch to fix, but rather a fundamental property of how transformers work. Every token you add to that window leaves less cognitive space for new reasoning, which means the model becomes a better retriever but a much worse thinker. Most organizations try to solve this by loading everything upfront. They cram 5 different agent instructions into memory along with 7 approved skills and 3 domain guides. Then they add 10 guardrails and 100 examples just to be safe. By the time the user even asks a single question, the reasoning space is already full. The agent starts the conversation at a massive handicap because it's carrying too much weight. Progressive disclosure fixes this by changing the starting point. Instead of loading everything at once, you load nothing. You start with descriptions, metadata, and lightweight signals. The agent scans those signals to figure out what's actually relevant to the user's request, and only then does it pull in the full context. Skills stay light by using front matter until they are actually triggered. Front matter is a simple convention from the world of documentation where a small section of metadata sits at the top of a file. It summarizes the document so you don't have to read the whole thing to know what it's about. For a skill, this front matter contains the agent's name, its domain, the types of requests it handles, and its output format. That's usually about 60 tokens. While the full skill file might be 3,000 tokens of detailed workflows and guardrails, the front matter remains stripped down and fast. To see how this works in practice, imagine a parent agent receiving a user request. It doesn't immediately spin up 5 specialists. Instead, it reads the front matter for each one to see who is qualified. The registry shows a sales specialist for deal mechanics, a finance specialist for approvals, and an HR specialist for policy. When a user asks why a customer wants a discount and how it impacts the business, the parent agent sees that this touches both sales and finance. It instantiates exactly those 2 specialists, leaving the other 3 dormant and out of the context window. The token math here is brutal. In the old model, you might load 7 agents at startup, which burns 21,000 tokens before the reasoning even begins. That leaves the model with only 79% of its capacity for the actual work. It is essentially working at a deficit just to carry its own overhead. In the new model, you only load the front matter for those 7 agents, which costs about 420 tokens. This leaves over 99,000 tokens wide open for reasoning. When the work arrives and you pull in 2 full specialists, you've only used about 6,000 tokens total. You still have more than double the reasoning capacity compared to the old way of doing things. This process is called skill matching. The orchestrator doesn't have to guess which specialist to use because it simply reads the metadata. If a request comes in about returns, the metadata points to the customer service specialist and the system loads it. If the request involves accounts payable, the finance specialist gets the call. These descriptions in your front matter act as a routing index that lets the parent agent make smart decisions without burning through its memory. These descriptions have to be incredibly precise to work. If you just write that an agent handles customer issues, the description is too broad for the orchestrator to be useful. It won't know the difference between a refund and a general complaint. If you write that it processes refund requests and manages dispute escalation, the orchestrator knows exactly when to call. Ambiguous descriptions lead to false routing, which causes work to bounce between agents until the context fills up with failed attempts. Minimal context leads directly to maximum reasoning quality. This isn't just a metaphor, it is something you can actually measure. A model with plenty of breathing room produces fewer hallucinations and much better logic. A model running at 90% capacity is noticeably worse than one running at 50%. Progressive disclosure keeps you in that sweet spot by loading only what is necessary and unloading it the moment the work is done. This is the real architectural reason why skills matter. They aren't just about automation, they are about context efficiency. They represent the difference between an agent that thinks clearly and one that is struggling under its own weight. This is how you keep intelligence sharp even when you're building at an organizational scale. Building the Today skill, a practical guide. Let's look at what this actually looks like when you sit down to build it. You are going to create a skill called Today that generates your morning rundown. This isn't a generic briefing or a summary of what someone else thinks you should see. It is your personal rundown based on how you actually work and what needs your attention right now. You start with the workflow by looking at what you do when you first sit down in the morning. You probably check your calendar, skim your email for urgent replies, and note any deadlines. You are building a mental model of your day, and that specific sequence becomes your direction. In your skill file, step 1 is retrieving today's calendar events using the native M365 connector. You filter for events before 5 p.m. and sort them chronologically while extracting the attendees and descriptions. Step 2 involves pulling email from the last 12 hours and filtering out the noise like automated notifications or promotions. Step 3 synthesizes a brief that shows your meetings in order and flags only the emails that actually require action. Finally, step 4 formats everything into a scannable summary that fits your preferred structure. That is your direction. It is specific, it doesn't guess what you need, and it follows a very defined sequence. It uses native connectors that are already secured by your IT policy rather than relying on custom APIs or messy workarounds. Next, you look at the blueprints. This is where you store the context the agent needs to understand your personal preferences. Maybe you organize your week with themed days where Mondays are for planning and Wednesdays are for execution. You have specific people who are always a priority and a standard way you like to see information. All of that lives in a separate references folder, so it doesn't have to be rewritten every time you update a preference. You can create a file for your planning logic that tells the agent to focus on strategy on Mondays and delivery status on Wednesdays. You can also create a list of VIP senders like your boss or your team lead so their emails always get flagged. You might even add a JSON file with noise filters to automatically strip out anything with an unsubscribe footer or system notifications. The solutions folder stays minimal here. You might just have one Python script that takes your filtered email list and turns it into a one-sentence summary for each sender. You aren't asking the agent to guess what is important. You are giving it a specific tool that handles the summarization consistently every single time. To execute this, you go into Copilot Studio and drop in your skill file, your blueprints, and your script. You connect the Gmail and calendar tools that your IT department has already approved, and then you run a manual test. You just type "was today" and let it work. The agent follows your workflow by retrieving your calendar and reading your noise filters. It applies your planning logic and generates a summary that is specific to how you think. 3 minutes later, you have a rundown that actually matters to you. The real magic happens after you use this for a couple of weeks. The agent logs every execution, which allows you to provide direct feedback. If the brief misses a meeting that was moved to 2 p.m., you tell the agent. It reads that feedback, compares it to the calendar, and updates its own rules to catch those time changes in the future. If you decide you want more aggressive email filtering, you just say so, and the agent updates the noise filters for you. Every one of these refinements makes the system better. You don't need an engineering team or a code editor because you just use the tool and tell it what's wrong. This is recursive building in action where your skill gets smarter as your own preferences become clearer. This is just a single skill that is narrow, useful, and focused on one outcome. However, it is built on the exact same architecture that scales to complex systems across an entire company. It uses the same structure, the same connector discipline, and the same self-healing logic. You are moving from a single personal agent to an organizational fabric using the same foundation. Recursive building, the feedback loop. Most organizations fail at agent architecture because they try to build the perfect skill before anyone ever uses it. They spend weeks in design meetings. They write massive comprehensive instructions. They try to anticipate every single edge case and document every possible outcome. Then they finally release it to production and it breaks immediately in ways they never saw coming. Stop doing that. The way you build reliable skills isn't by designing everything perfectly upfront, but by deploying something incomplete and learning from the inevitable failures. This is recursive building. It is the only way you will ever reach the hit rates that actually matter for your business. The starting point for any skill should be a walkthrough. Instead of handwriting a skill from scratch, you teach the agent the workflow by actually executing the task together. You act as the first user while the agent serves as your assistant. As you work through a real task, you think out loud and explain your logic, showing the agent what matters and what can be ignored. The agent watches you, logs your sequence, and notes which decisions you make and why. It captures the implicit rules you apply without even realizing it. Think about what this looks like when you're building a customer intake skill. You don't start by writing a long list of directions, but instead you walk through a real inquiry with the agent, shadowing your every move. You might say that a new customer inquiry just arrived, and the first thing you do is check if they already have an account in the CRM. The agent watches and logs that specific step. When you see they aren't in the system, you look at the inquiry type to see if they want a product or a consultation. You read the email and tell the agent this is a product inquiry, and the agent notes that specific decision. Because it's a product inquiry, you explain that you need to check inventory before committing to anything. You log in, check the stock, and see that while there are 2 units, one is already promised to another order. You tell the agent that only one is actually available and note that in the intake. You create a record showing the available inventory while the agent captures the logic that lives in your head. Step by step and decision by decision, the agent isn't guessing because it's observing how you actually think through the problem. After this walkthrough, the agent synthesizes what it learned into a set of directions and proposes a workflow based on your actions. You review it and realize it missed the fact that you always check the customer's industry first because pricing varies by sector. The agent updates the workflow and you walk through another intake using that updated logic. It executes much more accurately this time because it watched you work twice. Then comes the moment most people fear. You release it to production. It isn't perfect and it's definitely incomplete compared to your original vision, but it is functional enough for real work to flow through it. And then it fails. It fails specifically and measurably. A customer intake comes through and the agent misidentifies the inquiry type or forgets to check the inventory. Maybe it applies the wrong pricing because it missed a rule about volume discounts, but the failure is concrete and visible. You shouldn't be embarrassed by this because this failure is actually data. This is the agent telling you exactly what it doesn't understand yet. You don't fix this by rewriting the directions from scratch or assuming the entire approach is broken. Instead, you isolate the failure and show the agent that it didn't catch a service request masquerading as a product question. You pass that failure case back to the agent and tell it what it should have detected so it can update the workflow. The agent reads the failure, updates its internal rules, and refines the logic for identifying inquiry types. It adds a new example to its memory to distinguish between product and service inquiries in the future. When the next intake of that type comes through, the agent gets it right and you move on to the next challenge. If you repeat this over 5 or 6 iterative loops, those small failures accumulate into deep understanding. Each loop teaches the agent something new, and each failure becomes a rule that prevents the next mistake. By the 5th loop, your hit rate is usually at 90%, and by the 6th, you're approaching 98%. You reached operational reliability not through a perfect initial design, but through accumulated learning. This is why skills are self-annealing. They heal because every single deployment teaches them something, and every failure becomes a refinement. You aren't trying to predict what will break, you're letting the actual work show you. Human builders often hate this process because it feels like they're releasing unfinished work. In reality, you are, but unfinished work that learns is infinitely more valuable than finished work that can't adapt. This is how you move from theory to practice and from design to actual reliability. Governance, the architect's guardrails. Once you've built a reliable skill and proven the concept, you're going to face a problem you didn't see coming: proliferation. The moment you deploy one working agent, someone from another department is going to ask if you can build one for them. Then another person asks, and then another, until 6 months later you have 40 agents running across the entire organization. No one knows which agents exist, what access they have, or who actually owns them. Some are calling live systems and making decisions about money, while others have access to sensitive data, and suddenly you've created a governance nightmare. This is shadow AI. It's the exact same thing that happened with unsanctioned spreadsheets and homegrown databases back in the 90s. Teams built what they needed because they couldn't wait for IT, and now they're doing the same thing with agents. They're deploying agents in Copilot Studio without registering them or connecting to systems without a security review. They are exposing data because no one told them not to, and this risk isn't just hypothetical. If an agent with overly broad access reads something it shouldn't and that data leaks, your company faces massive compliance violations. Governance isn't just bureaucracy, it is architecture. It's the only thing standing between a controlled system and total chaos. It all starts with the principle of least privilege at the tool boundary. Every agent needs access to do its job, like a sales agent needing the CRM or a finance agent needing the general ledger. However, access to the CRM shouldn't mean the agent can read every single file in the system. It should mean the agent can read customer records for its specific organization and write to the opportunity table. It shouldn't touch employee records or financial data because least privilege means the agent has exactly what it needs and nothing more. This is where MCP becomes vital for governance. When an agent calls a tool through MCP, that tool is protected by authentication, rate limiting, and scoping. The organization's control plane, IT and security, defines exactly what each agent is allowed to do. The agent doesn't get broad access just because it asks. It gets constrained access by design. MCP servers expose tools with very specific parameters, allowing an agent to update a customer status but blocking it from reading financial history. It can create a new opportunity, but deleting one requires a human to step in. These guardrails are encoded at the tool level rather than in the agent's instructions. This means the agent can't override them with creative prompting because it hits a hard architectural boundary and stops. But we have to realize that some decisions can't be coded into a guardrail. They require human judgment and validation, which is why having a human in the loop is non-negotiable. When an agent recommends a large discount, it shouldn't be allowed to execute it alone. It needs to flag that for human approval. If an agent suggests terminating a service agreement or processes a refund above a certain amount, it should queue those actions for review. These are high-impact actions with real business consequences, so the agent shouldn't own the execution. The agent owns the reasoning, but a human must own the final act. You need to write these explicit guardrails into the direction. You tell the agent that if a discount exceeds 10% or a refund is too high, it must escalate to a manager. These aren't optional suggestions. They are part of the core specification. However, escalation only works if you're actually tracking who is doing what and why. That is what we call auditability. In an A2A mesh, you need to know which agent made a recommendation and what data it used to get there. You aren't doing this for paperwork, but for learning and tracing failures. When something goes wrong, you need to be able to reconstruct the chain to see who asked whom to do what and what the context was at the time. This is the difference between control plane thinking and data plane thinking. The data plane is where the agents actually work, calling tools and generating outputs. The control plane is where you enforce the rules. You aren't trying to micromanage every single decision in the data plane, but you are setting the boundaries. The control plane is where you register agents, define their scope, and set those critical approval thresholds. For M365 admins, this means you have to treat agent governance just like application governance. You need to know which agents are deployed, who owns them, and what systems they touch. You need to see the escalation rules and the audit trail, because these aren't optional questions. These are infrastructure questions, and without answers, you don't actually have governance. You just have hope. The most common governance failure is an agent that nobody owns. It's running and making decisions, but when it eventually breaks, no one knows who to call to fix it. You have to assign ownership by giving each agent both a business owner and a technical owner. Make them accountable for the updates, the failures, and the security of that agent. Governance isn't about restraint, it's about permission. It's how you give agents the freedom to operate confidently because they are running within boundaries you control. Graph connector, schemas, semantic contracts. Your schema is not just a technical document, it is a contract between your data and the reasoning system that needs to use it. Most organizations treat schemas like a clerical mapping exercise. They decide that a specific field in the CRM maps to a certain field in the connector, or they link a table to a content type. While this work is necessary, it isn't strategic. The schema ends up as a generic list of field names and data types that looks more like an inventory list than a blueprint. This approach fails when you design for agents because an agent doesn't read a schema the way a database does. A database only cares about data types and relationships to ensure it queries a string or a number correctly. An agent cares about meaning. It needs to understand what a field represents, why it matters, and how that information relates to a specific decision. When you give an agent a field called last contact date, it needs to know more than just the calendar day. It needs to know if that date signals customer engagement, if it points to a churn risk, or if it acts as a leading indicator for a renewal. The semantic meaning of the field determines whether the agent uses it correctly, not the data type. Moving beyond simple field mapping to relevance signaling changes everything. Relevance signaling is how you tell the agent which specific fields actually matter for reasoning. Instead of just listing 50 fields in a customer record, you are marking the ones that carry a real signal. 30 of those fields might be administrative data like account numbers or internal codes, while 20 of them track behavioral patterns like purchase history and support ticket volume. If the agent doesn't know which fields to weight, it treats contact information with the same importance as customer health. It might build a recommendation based on a zip code instead of a declining engagement score. Signaling tells the system what to prioritize. In your schema, this means you must add metadata that goes deeper than the field name. Don't just label a column engagement score. You should add details like signal strength, high, and relationship correlates with renewal. For a support tickets field, you might add an interpretation note stating that high volume over 90 days indicates a churn risk. You are essentially building a reasoning map for the intelligence to follow rather than just a storage map for data to sit in. However, relevance signaling only works if the data in that schema is actually trustworthy. This is why access control lists, or ACLs, are so critical to the process. In the old world, we treated ACLs as a simple security layer enforced at the database level where a user either had permission or they didn't. In the world of agents, these permissions become part of the semantic understanding. If an agent tries to reason about a customer but cannot see their purchase history due to a restriction, it doesn't just stop working. It often makes inferences based on incomplete information or starts to hallucinate details. It reaches a bad conclusion because it has no idea what information is missing from its view. When you design your schema, you cannot treat security controls as an afterthought because they are a core part of the contract. Your schema must document what data exists and exactly which agents can see it under specific conditions. If an agent has permission to see general account info but not the financials, the schema needs to signal that boundary clearly. You might include a note that if the financial summary is not visible, the agent should not attempt to infer financial capacity. Telling the agent what it doesn't know is often more important than showing it what it does. This has a massive impact on how the system handles ranking and summarization. When an agent summarizes a record, it prioritizes the fields you've marked as high signal. When it ranks search results, it weights those fields based on their relevance to the task. If your schema is vague, the agent is forced to guess. It might summarize a complex customer history by focusing on the office address instead of the health metrics. Poor schemas lead to poor summaries, and poor summaries lead to bad business decisions. This is exactly why a full crawl is more valuable than simple incremental updates. When you first ingest your data, you are establishing that semantic contract. The schema you build on day one sets the expectations for what fields mean and how they relate to one another. If you change permissions later or shift the meaning of a field, an incremental update might miss that shift in context. The agent might continue using the old logic from the original schema. A full crawl reestablishes the entire contract and tells the system what the data landscape looks like right now. It forces total clarity on permission boundaries and reasoning expectations. Your schema is the primary way that data talks to intelligence. If you get this right, your agents will reason with incredible clarity. If you build it carelessly, those same agents will start to hallucinate. This is where architects provide the most value by building contracts between data and reasoning that actually hold up at scale, than measuring ROI beyond minutes saved. This is where most organizations get it wrong when they try to measure agent performance. They deploy a new skill and immediately start tracking time. If an agent cuts the time to create a quote from 60 minutes down to 3, they announce that they've saved 57 minutes per quote. They multiply that time by the number of quotes per year, calculate the labor value, and declare victory. They think the ROI is proven and the budget is justified. But that logic is flawed. The time savings are real, but they are the smallest possible measure of what an agent actually changes in a business. The uncomfortable truth is that when you give a team 57 minutes back, they don't just pack up and go home early. They don't work fewer hours, but they do start working differently. They shift that new capacity toward work that carries more value. This is known as the productivity paradox. Total hours worked usually stay the same, and utilization looks unchanged on a spreadsheet, but the actual output of the work is transformed. A salesperson who used to spend an hour on a single quote now finishes it in 3 minutes. They don't spend the rest of the hour taking a break. Instead, they might handle 18 quotes in the time it used to take to do 3. They might use that extra time to focus on account strategy or qualify leads more carefully because the quoting process is no longer a bottleneck. The input of time stays the same, but the output of the person changes completely. This is why you should focus on measuring capacity gained instead of just minutes saved. Capacity gained represents what your team can do now that was physically impossible before. Before you had agents, you might have processed 20 customer intakes a day because each one took 30 minutes. After implementing agents, you can process 80 intakes a day because the task takes 7 minutes and your staff is now managing the agent instead of doing the manual labor. The salesperson who managed 5 customers can now handle 15, and the analyst who wrote 3 reports a month can now produce 12. This isn't a hypothetical benefit. It is a structural change you can measure. You should track this at 3 distinct levels. The first level is task velocity. This measures how fast a person can complete one single unit of work. If a sales team drafts presentations, you can set a baseline of 45 minutes per deck. If an agent brings that down to 32 minutes, you've improved velocity by 29%. However, velocity alone doesn't prove value. A presentation that gets finished 10% faster means nothing if it doesn't help close a deal. Velocity is just a diagnostic tool to show the agent is working, but it doesn't prove the organization is winning. The second level is workflow cycle time. This tracks the time it takes to move work from the very beginning to the very end of a process. Instead of looking at one task, you look at the whole chain. A quoting workflow might move from the initial inquiry to a signed contract. If the baseline was 8 days and agent orchestration brings it down to 2 days, you've achieved a 75% reduction. That speed changes how people behave. When a customer gets a quote back in 2 days instead of 8, they stop shopping around and the deal closes faster. That time reduction creates a pressure that changes decision-making further down the line. The third and most important level is business outcome. This is the only metric that the finance department actually cares about. It isn't about how fast things move, but what actually changes for the company. A sales team that closes deals faster will eventually move more deals and close higher value contracts because they have the bandwidth to qualify leads. A support team that handles 30 escalations instead of 10 will reduce churn because they are more responsive to customer needs. When a marketing team publishes 12 reports instead of 3, they can run more experiments and find new growth opportunities much faster. This is where the statistic about having 66% more customer meetings comes from. A sales organization with more capacity doesn't just work 66% harder than before. It works differently. They schedule more meetings because they finally have the time to do it. They qualify prospects more aggressively because they aren't drowning in administrative paperwork. They sell more because the structural constraints have been removed. These 3 levels build on each other. Task velocity proves the agent is functional. Workflow cycle time proves the process has changed. Business outcome proves the company is actually growing. Most organizations stop at the first level. They track the minutes and declare the project a success. They completely miss the second and third levels, which is where the real transformation lives. A sales team that can handle double the pipeline because quoting is fast isn't just saving time. They are changing the entire revenue trajectory of the company. That isn't a story about efficiency. It is a story about business transformation. When you sit down to build your measurement framework, you must anchor it to the business outcome. Ask yourself what specific outcome improves because the work is moving faster. Then you can work backward to find the workflow changes and task improvements that made it possible. This is how you move the conversation from being more efficient to being more valuable. The agent-operated organization. Moving from AI-assisted to agent-operated isn't just a tech upgrade, It's a total shift in how your company actually functions. You have to redesign how authority and accountability are handed out across the entire organization. Most companies today are still stuck in the old assistance model where IT builds the tools and the business units just use them. In that world, IT owns the platform while the business units own the results, which is fine when you're just dealing with spreadsheets or dashboards. But that logic falls apart the second you have autonomous agents making real decisions on behalf of the company. An agent-operated organization flips that script by pushing authority out to the edges. Every department becomes a builder and every function owns its own portfolio of agents. Sales builds for sales, finance builds for finance, and HR builds for HR. Instead of waiting months for IT to build a generic tool that doesn't quite fit, these teams design agents that encode exactly how they work. They are turning their own expertise into digital logic. But here's the problem. Decentralization only works if you have a rock-solid central governance framework. You can't have 80 different agents running wild with nobody watching the big picture. If the sales team builds an agent that exposes sensitive customer data that finance also needs, or if an HR agent makes a call that breaks compliance rules, the whole system collapses. The moment you let everyone build, you have to tighten the leash on control. This is where the central governance layer comes in. Teams like IT, security, and compliance stop being the builders and start being the architects. They set the boundaries, define which systems an agent can touch, and enforce the rules for when a human needs to step in. They aren't building the agents themselves, but they are building the safe playground where those agents live. The business units get total freedom, but only within those preset constraints. This creates a very clean division of labor. IT provides the plumbing, like the server connections for the CRM, and tells the business exactly what can be read or written. Then they hand it over. Finance might say they need an agent to approve any purchase order under $5,000, so they build it, test it, and own its performance. The governance layer just makes sure that agent can't buy things from restricted categories and logs every single move it makes. The business unit decides the logic, but the governance layer decides the limits. That's why the agent champion role is so vital. You need to pick one person in every department to own that team's agent portfolio. They need to understand the business side and work directly with IT to design the right workflows. While this isn't a full-time job for most people yet, it is a massive responsibility. Without a champion, these agents become orphans that nobody looks after, and they eventually just sit there and rot. The champion also acts as the bridge between the business needs and the security rules. If sales wants to show customer payment history through an agent, the champion is the one who negotiates the details. They might agree to show the payment date and status but keep credit card numbers completely hidden. They speak both languages, translating business goals into security requirements. This helps you avoid the biggest bottleneck coming in 2026, the center of excellence. A lot of companies set up a central COE to build every agent and manage every standard. On paper, it sounds smart, but in reality, it becomes a massive traffic jam. Every department ends up waiting in a long line for the COE to build their specific tool, and when the COE can't keep up, the work just stops. People go back to doing things manually, and your AI advantage disappears because the bureaucracy moved too slowly. The fix is to turn the COE from a builder into a coach. Instead of making the agents, the Center of Excellence builds the templates, the training, and the security frameworks that everyone else uses. They do the code reviews and handle the weird security exceptions, but they govern at the platform level. The business units are the ones actually doing the building. This is the shift from reacting to problems to actually designing a system. Right now, most IT teams are just firefighters. They wait for something to break or for a department to complain, and then they rush to fix it. But when you move to an agent-operated model, the firefighting stops. You spend your time designing the landscape and setting the bumpers that keep everyone safe. You move from tactical fixes to strategic architecture. The organization that figures this out first, the one that actually lets departments build while keeping central control, is going to win. Everyone else is going to spend the next few years just trying to catch up. Roadmap to 100x, the 3-step path. The plan is clear and the logic is solid, but you can't wait 6 months to start. You need to move from understanding how this works to actually building it right now. Step 1 is all about finding your bottlenecks. You aren't trying to automate your entire company on day one. Instead, you need to find the specific, high-volume problems that are dragging everyone down. Don't look for the cool problems. Look for the places where work piles up and decisions get stuck in a queue. Every department has one of these. In sales, it might be that proposals take way too long to write, so deals just die while waiting for a contract. In finance, it's usually manual expense reports that make everyone angry. HR might be stuck manually sending the same 5 emails to every new hire. These aren't fancy problems, but they are boring, repetitive, and they happen constantly. Just pick one. Where you start actually matters more than being perfect. You should always aim for front-end tasks that people actually see and feel. If you build a sales agent that cuts down the time it takes to close a deal, the team will tell you if it's working immediately. If you start with a back-end warehouse agent, you might not see the actual value for a month. Front-end work gives you that instant feedback you need to know if you're winning. Step 2 is building a specialist. You aren't trying to create a do-it-all AI. You want one focused agent that owns that one specific bottleneck. If you picked sales, you build a proposal agent. It should know your pricing, your legal terms, and which clauses go to which customers. That is its entire world. You build this in Copilot Studio using the DBS framework. You give it direction for the workflow, blueprints for the brand standards, and solutions for the pricing math. You hook it up to your CRM, but you set very strict boundaries on what it can actually touch. You keep a human in the loop for any big discounts, and you log every single recommendation it makes. Then you just run it. You watch it work, find the mistakes, and fix them. After about 5 rounds of this, it should be hitting 95% accuracy. Then you look at the hard numbers. If you were doing 10 proposals a day before and now you're doing 40, that's a win. If your cycle time dropped from 8 days down to 2, you now have the proof you need to justify the next move. Step 3 is about scaling that fabric. Now that you've proven one specialist works, you start connecting it to others. That proposal agent shouldn't live on an island. When a sales rep starts a new contract, that agent should be able to call the finance agent to check the pricing or the compliance agent to verify the legal language. Each one handles its own tiny domain, and a parent orchestrator keeps them all in sync. But don't try to build everything at once. You have to cascade. Since the proposal agent is working, your next move is to find the next bottleneck, like contract approvals. You build an approval agent that knows who has the authority to sign off on what. Now, the proposal agent just hands the finished work to the approval agent. You've officially connected 2 specialists. Whatever you do, don't get distracted by shiny objects. There's always someone who wants to automate a complex manufacturing schedule or some deep financial model because it sounds impressive. Those are fun projects, but they don't actually make the business move faster. Front-end specialists are the ones that move deals and change the employee experience. Back-end stuff is a nice to have, but front-end acceleration is what keeps you alive. The path is simple. Find the bottleneck, build the specialist, connect them, and then repeat. Don't spend months planning. Find the pain, build the fix, and deploy it fast. By the 3rd month, you'll have a few specialists working together. By the end of the year, you'll be operating at 100 times the speed of your old manual processes. That is how you move forward. Troubleshooting the fabric. You've built your agents, you've set up the orchestration, and you've configured every connection. On paper, the system should be working perfectly, but then it doesn't. It's not a catastrophic crash. It's a quiet failure. A skill doesn't trigger when it should, or the parent agent routes a task to the wrong specialist. Maybe the handoff between agents fails silently. The system keeps running, but it stops doing what you actually designed it to do. This is the exact point where most organizations give up. Something broke and the fix isn't obvious, so the problem starts to feel architectural rather than just a small bug. Instead of digging in, they disable the agent and go back to manual processes. They never actually find out why it stopped working in the first place. The reality is that the failure is usually mundane. It's a diagnostic issue, not a systemic one, and you just need to know where to look. Start with skill triggering. Your skill exists and it's deployed, but the work that should trigger it just sits there. The orchestrator reads the user request, yet it doesn't invoke the skill when it's supposed to. This almost always comes down to the description, specifically the front matter metadata. You have to remember that the orchestrator doesn't read your full skill instructions to decide whether to trigger it. It only reads the description. If your description says, "This skill handles customer refund requests, validates eligibility, and notifies the customer," the orchestrator scans those specific words. When a request arrives saying, "Customer wants to return an item purchased 6 months ago," the orchestrator looks at your description and sees no mention of returns or item processing. Because of that missing keyword, it doesn't trigger the refund skill and routes the request to a generic handler instead. The fix here is purely mechanical. You need to rewrite the description to signal exactly what the skill handles. Change it to say, "This skill handles customer refund and return requests, validates eligibility based on purchase date, and processes execution through the payment system." Now that the description is explicit about returns, the orchestrator recognizes the request and triggers the skill every single time. Ambiguity creates a different kind of failure where 2 sub-agents claim the same task. Imagine a request comes in to update employee benefits. The HR agent claims it because it handles benefits administration, but the payroll agent also claims it because it's payroll related. The orchestrator doesn't know which one to call. It might invoke both, which creates duplicate work, or it might just pick one arbitrarily and cause massive inconsistency. Sometimes it just gives up and escalates to a human, which completely defeats the purpose of your automation. The solution is explicit domain scoping. The HR agent shouldn't just own benefits in a general sense. It needs to own benefits eligibility, enrollment, coverage changes, and dependent updates. Meanwhile, the payroll agent owns payroll deductions, tax withholding, and direct deposit. When you define it this way, you aren't overlapping anymore. A request to update coverage is clearly HR, and a request to change deduction amount is clearly payroll. No more ambiguity and no more routing errors. The compact context problem is a bit more subtle. Your agent starts a workflow and reasons clearly through the first few steps, but by step 5, something shifts. the reasoning becomes lazy and the agent starts skipping analysis. It begins making assumptions instead of checking facts, or it starts hallucinating details instead of retrieving them. This happens because the context window is filling up. If you loaded 5 specialist agents, their full instructions, blueprints, and example cases at startup, there's barely any room left for new reasoning by the time you hit step 5. The agent isn't actually thinking anymore. It's just pattern matching, which is really just a polite way of saying it's guessing. The fix is aggressive context minimization. Do not load every specialist at the start of the process. Instead, load the descriptions first. Load the one specific specialist you need for the current task, let it execute, and then unload it immediately. When the workflow moves to a new domain, you load the next specialist. By keeping the reasoning space open, the agent stays sharp because it isn't drowning in unnecessary context. Authentication and connection failures happen when those agent-to-agent handshakes fail without a word. One agent calls another, and they're supposed to establish a secure connection, but something in the credentials or the endpoint is wrong. The call fails, yet neither agent reports the error clearly. The orchestrator has no idea a problem occurred, so it just waits for a response that's never coming. The user just sees a timeout or a generic error message. When you finally dig through the logs, you find a connection refused error because the agent tried to use expired credentials. The handshake failed before the work even had a chance to start. This is why you need centralized credential management. Credentials for these connections shouldn't be stored inside individual agents or hard-coded into your configurations. They need to live in a dedicated secrets management system. The orchestrator should retrieve those credentials at the exact moment of execution. If the credentials are expired, the system knows it immediately. It can refresh them or escalate the issue, but it won't result in a silent failure. Finally, you have to watch out for static skill decay. You might have built a skill 6 months ago that worked perfectly, but now it's making the wrong call in 20% of your cases. The code for the skill hasn't changed at all, but your organization has. Your policies evolved, your approval thresholds shifted, and your customer segments were refined. The skill is still executing logic that worked last year, but it's no longer aligned with how you actually work today. This is exactly why skills require quarterly reviews. You don't necessarily need a full rewrite, but you do need a checkup. You should examine the skill's recent decisions and check them against your current policy. If your guidance has shifted, you update the blueprints. If thresholds have changed, you refine the rules. Keeping the skill synchronized with your organization's living reality only takes a few hours, and it prevents a full year of silent decay. Future-proofing, the open standard. Vendor lock-in is the silent killer of enterprise architecture. You build a whole system around one platform's specific way of doing things, and you optimize everything for their APIs. You write code for their semantics and train your entire team on their specific tools. Then, 5 years down the road, a much better platform emerges. But you're stuck. You can't migrate because the switching cost is catastrophic. You end up staying with inferior technology just because leaving is more painful than staying. This is the exact risk most organizations are facing with AI agents right now. You're building your orchestrations in Copilot Studio and designing workflows in a specific Microsoft framework. You are essentially betting your entire automation future on one company's roadmap. But what happens if Google releases an agent platform that's objectively better in 2 years? What if AWS builds something that costs half as much? You've painted yourself into a corner where you own the software, but you don't own the ability to move your data. The only real antidote is protocol-based design. The skill format we've been building throughout this deep dive isn't proprietary to Copilot. It isn't a Microsoft-only standard. It's completely vendor-neutral. The skill markdown file with its directions, blueprints, and solutions is platform-agnostic. The same goes for the agent card, the MCP protocol for data access, and the A2A protocol for communication. None of these tools lock you into a single vendor. Claude can read a skill file just as easily as ChatGPT or Gemini can. The instruction format is human-readable and completely portable. If you build a skill today in Copilot Studio and a better platform becomes dominant in 3 years, you won't have to rewrite everything from scratch. You can just upload that same skill file to a different orchestrator. The workflow logic doesn't change and the direction stays the same. The only thing that actually changes is the runtime. This kind of portability is your architectural insurance policy. You aren't betting on Microsoft owning the future of AI. Instead, you're betting on standards and protocols. You're betting on the idea that good design matters more than any single platform. It's the difference between building your house on shifting sand or solid bedrock. This shift also changes what the word skill actually means in a professional context. Right now, many people think a skill is just a configuration or a set of prompts inside Copilot Studio. That's a very narrow view. When you move toward protocol-based thinking, a skill becomes a full specification of how work should be done, and it becomes independent of the tool that's actually executing the task. This is the big move from prompting as a skill to systems design as a skill. In the old model, a skill was just a really well-written prompt. You engineered the phrasing, you got the examples right, and you tweaked the tone until it worked. But that's tool-specific and very brittle. If the underlying model changes even slightly, that prompt might stop working entirely. In this new model, a skill is a design. It describes the entire workflow, the logic, the constraints, and the context. The prompt itself is just an implementation detail. Because the skill is platform agnostic, you can set it up on Copilot Studio with one set of prompts or on Claude with a different set. The intellectual structure of the skill never changes, only how you express it to different systems. This elevation of skill design is what architects should be focusing on as we move toward 2026. You shouldn't be worrying about how to write better prompts for one specific tool. You should be learning how to design systems that work across any agentic platform. It's not about configuring a specific studio. It's about architecting intelligence into your organization that exists independently of any single vendor. This matters because the agent ecosystem is about to explode. Google has its own version of agent-to-agent communication, and OpenAI is building its own frameworks. Microsoft has Copilot Studio, and AWS is right behind them. Every cloud vendor is trying to own the orchestration layer. But the standard that wins won't be the one with the most licenses. It will be the one that is the most portable and interoperable. Organizations that design for these protocol-based standards are the ones that win because they have the freedom to move. They can choose the best tool for the job at any given moment. They aren't locked into a decision they made years ago. They are architecting for a world where half of all work is agent to agent, where those agents span across different vendors, and where the work itself is the only thing that matters. Your job as an architect is to design that intelligence layer. You don't need to become a narrow expert in one specific software suite. You need to become an expert in building agent systems that transcend any single vendor. That is how you future-proof your career, and that is the only mandate that actually matters. Prompting is just a phase, but orchestration is the structure that actually scales. You need to build your agent fabric now. Connect with me on LinkedIn if this changes how you think about intelligence. If this helped, leave a review. It matters.